Hello guys, welcome back to my channel, and this is the part 4 of electrical series. So today I am going to deal with some important questions again, and maybe another two part will come very soon. So don't waste the time and let's start the video. The first question is, what is transducer, transmitter, and the difference between both of them? So this question is very important because most of the surveyor are asking these questions. What is transducer and transmitter? Because most of the people are confusing in between transducer and transmitter. Now you can understand it very well. Transducer, what is transducer? Transducer is a device that converts one form of energy into the another form. It means the one form of energy, they are in various ways, like in temperature, pressure, sound and light. These are the various type of energies. Okay, so they convert this into the electrical signal or voltage signal. That is the purpose of the transducer. Transducer, what they are doing, they just convert the one form of energy into the another form. Though one form of energy, like this is the input and this is the output. When you feed this temperature, pressure, sound or light, whatever the energy is there at the input side, this is the transducer. You will get a voltage signal or maybe electrical signal. Okay, so you are getting this is the main purpose of transducer. And what the transmitter is doing now? Transmitter, you can recognize from this word is transmitter, it means transmit. Okay, the main purpose is transmit. So what they are transmitting, they convert this electrical signal, whatever the coming from the transducer, electrical signal to current signal in 4 to 20 milliampere. Okay, 4 to 20 milliampere. Why this 4 to 20 milliampere we are taking, I will discuss in later because this is a long discussion. So electrical signal to current signal. Okay, current signal into 4 to 20 milliampere form, and they amplified the signal and transmit over the long distance. Okay, suppose you want to transmit the signal over a long distance. Suppose there is 100 meter, 200 meter, 300 meter distance. You want to transmit a signal. Okay, from the forward of the ship to the aft of the ship. You want to transmit the signal. So how you can transmit? Transducer. Let's suppose transducer is fitted on a water. It just measure this speed of the speed of the ship and just convert into a voltage signal. Okay, and this voltage signal is giving to the transmitter, and what transmitter will do, they just convert this voltage signal into a current signal. Okay, why we are taking this current? Maybe surveyor will ask you why we are taking this current. Because voltage, there will be always a drop in voltage. Why we are not taking the voltage? Why we are taking current only? In the voltage there is a drop, due to some resistance, because voltage will drop because cable having some resistance, and at a long distance some voltage will drop. But current, there is no drop, nothing. It will directly transfer the signal from one place to another place. Okay, one place to another place. Okay, so it just transmit a signal, but in the current form, whatever 4 to 20 milliampere. The main purpose of this is the transducer. Now you can, I think, understand very well. The transducer, they convert this into electrical signal going to the transmitter. Transmitter transmit electrical signal in a form of 4 to 20 milliampere current signal over a long distance. Okay, and then it taking by the receiver, output receiver, that is also a transducer. They convert this current signal into another form. Okay, so that is a long story. I will explain the working of the sensor, then I will explain everything each thing one by one. Okay, so now you can understand. Example, 4 to 20 milliampere pressure transmitter is there. Take a signal from pressure sensor and convert it into 4 to 20 milliampere current signal to be sent over the control system. This is the example. Okay, wireless temperature transmitter converts a temperature reading into a wireless signal for remote monitoring. Okay, so next question is the single phasing and safety equipments. How to guys, I will tell you, because some of the questions are coming maybe after that. So that is the big question. If there is some big question, I will discuss in a separate section, not here, because they need some detailed explanation. So I will not explain. Whatever the short question first I will cover, because otherwise video will be too long, you will not watch. So Next question is single phasing and safety equipment, how to do. Okay, so what is the single phasing? Single phasing, suppose you have 3 phase, any one phase is open circuited or any one phase may be open circuited, or some due to the loose connection it will disconnected from the circuit. That is the case of the open circuit, and due to this single phasing can occur sometimes. Okay, single phasing is a condition in a 3-phase electrical system when one of the phases is lost or disconnected, as I told before, often due to the blown fuse. Also the circuit having the fuses. Okay, and suppose your fuse, one phase fuse, 3 phase is there, 3 fuse is there, one fuse will be blown, then also the condition for the single phasing. Okay, because 2 phase will be go and it will take all the load of the motor. Due to the blown fuse, broken conductor, malfunctioning circuit breaker. And what are the safety equipments we are covering for the single phasing? There are different types of protective devices we are using. Generally thermal overload relay is the most common we are using, because it's always sense your whatever the current imbalance in the circuit. Overcurrent relay is better. You see the overcurrent relay is the like this wire is coming to the input of the overcurrent relay, then it going to the circuit. Okay, so this overcurrent relay having some setting. If the setting if the value of the current, let's suppose you said 105% of full load current. Okay, and when your current exceed this limit 105% of full load current, then what happens, this inside there is a metal strip, 3 metal strip, which continuously senses this current from the circuit, and due to this overheating it will bend and close the circuit. So it will just open the circuit. So overload relay just disconnect the circuit from the equipment. Okay, so power will not flow to the equipment. So thermal overload relay we are using. Phase failure relay also sometime we are using, because it detects the phase is properly coming or not. If there is any imbalance in the phase, it will disconnect the circuit. And sometimes differential protection relay. This is the most important protection. Here is not written, I think, the relay. Okay, so differential protection relay, what they are doing, we are taking, let's suppose some area, this is the one area we are putting here. I will explain here. This is the area, let's suppose. Okay, we are putting here one CT and we are putting here one CT. Okay, two side we are putting CT, this CT. We are protecting this area. Okay, whatever the cable is going, if there is any single phasing or anything happen in this protected zone, it will just disconnect the circuit. And what differential protection relay are doing, just senses this current, incoming current and outgoing current, because according to the Kirchhoff's law, the sum of the current entering and outgoing must be 0. Entering current plus outgoing current must equal to 0. So it basically what happened, entering current must be equal to outgoing current. If there is not equal, then there is imbalance in the circuit, and due to this CT will give signal to the relay and relay will disconnect the circuit. So differential protection relay I will explain in detail also. Just you can now understand. I will give the one basic, because here question is there. So you can understand the sum of entering current plus sum of leaving current must be equal to 0. If there is no 0, it will give signal to the relay and relay will disconnect the circuit. That is the differential protection relay. Differential protection relay. Okay, you understand? Now let's go to the another question. Okay, what are the question here? Single phasing safety equipment, how to work. I already explained everything, so better you can read this also if you want, but no need, I think I already explained everything. Okay, identify the source of phase loss. Okay, how to, it means how you are working with the single phase. Here they explain. So you have to first check, disconnect the power, check the fuses and everything. You have to just replace the faulty component if you found anything. Okay, so these are the things. Overcurrent protection and how to test. The overcurrent protection, it means the current exceed from some set point, then due to this overcurrent flowing from the circuit and it damage our circuit. Let's suppose this is our circuit and we have one set point 105%. We are setting this in overcurrent relay, and somewhere we are putting this setting, and if the current exceed this 105%, then what will happen? This will disconnect the this will disconnect the circuit breaker from the equipment, so that no power will flow to the equipment. So these are protection. So what are the protection we are generally using to protect our equipment, motors and another things? We are using the fuses, circuit breakers, overcurrent overload relay. Overcurrent relay also there is sometime we are using, and CT we are using basically. Okay, CT with the relay, because at some system there is a high current, we just transform this current into a lower current and then connected to the CT, and this CT is connected to the relay, and when this CT there is some current imbalance, this gives signal to the relay, and relay will disconnect the circuit. Okay, so we are using this CT also, you can understand it very well. Now next question, how to test the overcurrent protection device. So how we are testing the overcurrent protection devices? So there are basically two methods, like circuit breaker is there also, okay, ACB is there. You want to test its capability is working or not, because if current will exceed, it will not trip, then there will be very dangerous, because current will exceed and it will damage all the equipments and the motors and all the equipment connected to this power source. So we have to must care about these circuit breakers also. We have to test this, okay, it's really working or not. So how we are testing? We are testing by the two methods. First is the primary method and another is the secondary method. Okay, primary method are the easy one, because we can test in without any help, but secondary method basically in the dry dock. Basically dry dock, by the service engineer is coming for the ACB calibration, they are doing the ACB calibration, they are injecting. I will tell you now. First I will explain the primary injection method. What is the primary injection method? In this we are not doing anything. We take a beaker. Let's suppose we take a beaker. I will just explain you here. We take a beaker. This is color is not good. I will explain here. Okay, so we take a beaker. What we are doing? We take a beaker. Okay, let's suppose we are taking this beaker, and in this beaker we fill this fresh water. This fresh water is there. Okay, this is the fresh water, and suppose this is your bus bar. Suppose this is your bus bar, where the cable is connected, suppose this is R, and another bus bar is there Y, and another bus bar is here, like the black RYB, black phase is there. So we disconnect this cable, from the bus bar, which is coming from the generator or somewhere, and it's going to the ACB. Okay, so we disconnect this cable which is connected from the ACB. Okay, like suppose this is the circuit breaker. Okay, it's going to the ACB. This is our ACB. This cable is going, and this is coming from the bus bar, this bus bar, and it's going to the generator side. Okay, this is the generator side. So what we are doing? We disconnect the cable where this ACB, the cable is going to ACB. It means this one. We disconnect from here. Okay, we disconnect from here, and put this cable to a beaker. Put this cable, this R phase, Y phase, B phase, R, Y, B, to a beaker. Okay, then what will happen? We just add salt. Okay, we just add salt, little we are adding the salt, and at a time will come when this conductivity will increase, the freshwater conductivity will increase, and it will trip this ACB, and then we can measure the current there, how much current it is taking generally. This is the method of the primary method we are doing. So this is the primary method, and secondary method is nothing. We are just let's suppose in secondary method there is a CT. This CT is connected with a relay. Okay, and it's connected with the circuit breaker. Okay, so we inject this current at that input of the relay. We inject the current at the input of the relay and slowly increase the current, and when it's increase above this full load current, then this ACB will trip. So we are checking like this, we increase the current at the side of the input and increasing, at a time will come, then this breaker will trip, and we note down the current, at which current the breaker will trip. So basically these are the things how we are testing. So I just explain you guys. Okay, so this is the primary here. Primary, this is not correct. Basically surveyor will not happy with this answer. We have to tell salt bath test. This is the primary method. Salt bath test I already explained. And secondary injection, the current is injected. The current is injected at the relay secondary side. Okay, the test primary verifies the relay operation without involving entire power circuit, make it late, instant and more inconvenient for the maintenance. Okay, now I will explain another question. Two generator of unequal capacity you want to run in parallel. The surveyor will ask like this, already asked by somebody. Two generator of unequal capacity. Okay, if you have two generator, let's suppose your generator having 800 kilowatt. Okay, and another generator 200 kilowatt, you want to run with parallel. So how you can run in a parallel, because these two having different capacity, but it will parallel. Okay, it will run parallel, no problem. You have to synchronize the generator very properly. So how you can synchronize, we have to first check voltage, frequency and phase. Okay, frequency, it means speed. Okay, we have to set the speed properly, we have to check the voltage. Okay, and phase we will synchronize, with the help of 12 o'clock position. We will just close the breaker at just before the 12 o'clock position. Why we are doing this, I will explain later also. Now just you understand, voltage we have to maintain the voltage same, frequency same, both generator frequency same. Okay, frequency, it means speed of the diesel engine same, and this phase angle we will have to maintain same. Okay, this have to maintain same. And if you want to do in parallel, now just synchronize the generator, after that just close the circuit breaker, before 12 o'clock position. Before 12 o'clock, it means 11 o'clock position. In the synchronous scope you are checking manually, and you can just close the breaker that time, then it will come in a parallel, and it will share the load. How much it will share the load, because now I already explained you, one generator having 800 kilowatt and another is the 200 kilowatt. Then in parallel, how much they are sharing the load, it will share 400 kilowatt load and it will share 100 kilowatt load. Okay, they are sharing this load up to full capacity. Okay, because in parallel they are sharing equal loads, so they will share up to this much only, they will not exceed above this, Okay, so in a parallel they are doing like this. So this is the method I already explained, how you can synchronize. You can read this also, no problem. Synchronize the generator, control the load sharing, I already told you. Monitor and adjust the load distribution. Okay, you have to monitor the load distribution perfectly. Okay, use proper protective relays there. Okay, proper protective. This PID controller, this is a very good topic, and most of the time 90% chance surveyor will ask you this question. This PID controller, how they are basically using in a boiler, jacket cooling water system, in the ships. There are various machinery we are using the PID controller to control this one. Okay, P is another, integral is P is for proportional, I is for integral, D is for derivative. And why we are using this, I will explain just a little bit, very in simple word, but for detailed explanation I will make another video. I will just tell you the only few things. Okay, P stands for proportional. It means the suppose you have a one system, this is your set point. Okay, set point input. Okay, your input and your output. Okay, let's suppose you set point is 100 degrees Celsius and this input is coming from some chamber and input is let's suppose 90 degrees Celsius. Okay, but you want 100 degrees Celsius, so there is a difference in 10 degree. So this 10 degree is the error, 10 degree is the error. So you have to maintain this 10 degree for perfect synchronization, okay, because your system have to need 100 degrees Celsius. So you have to maintain 100 degrees Celsius inside a chamber, but now the temperature is 90 degree, they have to maintain this 10 degree error. So 10 degree error let's suppose this is the water. For this 10 degree error, this 10 degree error is compensated by this proportional controller. What the proportional controller? The output, whatever the output is generated by the proportional controller output generated, because this will generate some output, okay, proportional controller will generate some output which is directly proportional to this error signal, whatever the error signal. It suppose 10 degrees the error signal, it will react accordingly, and they will send this output, control output, according to this error signal. So okay, so 10 degree Celsius, they just try to maintain this 10 degree Celsius, okay, because this is the error, and they just increase the temperature. Like suppose there is some heating arrangement is there, they just increase this temperature with the help of proportional controller, because the output is directly proportional to the error signal, okay, But what will happen, this proportional controller, what will happen, they are unable to remove this error completely, because they will not remove this error completely. There will be some offset will be there, it means they will remove, but let's suppose they remove only 7 degrees Celsius, 3 degree still error is there. So this 3 degree error is the offset, this 3 degree is our offset, okay, this 3 degree is the offset, and this offset will removed by this integral controller. This 3 degree will be removed by this integral controller, because what integral controller is doing, integral controller just accumulate all the history, past history, it means whatever the past error we have and whatever the present error we have, they just accumulate all the errors and do the sum of the past error, it means 0 to t time past error, also sum of error, steady state error, past error plus present error. They will just do this past error and present error sum and integral of this, okay, then they send the controller output, it means integral of the past error and present error. It means whatever the error has before in the past and whatever the error is now present, they just sum this error and do the integral of this and send the output, that is the integral of the past error plus the present error. The integral controller is doing like this, okay. So this is the integral controller which remove the offset, whatever the offset is there, 3 degree, okay, 3 degree offset, they want to remove this. But here what will happen, sometimes there is a demand of the system is very high. Let's suppose the heating arrangement is frequently changing, 90 degree, 100 degree, 110 degree, then there is a frequent changes, but this offset controller is unable to remove as this much fast, okay, this much fast, they are not responding this much fast, okay, they are doing the work very slowly. But due to this fast acting devices, because the requirement is very high, then the temperature is changing very fast, then what will happen, there is a undershoot or overshoot is there, okay, undershoot and overshoot is there, and hunting is there. Hunting you can easily understand, hunting, it means frequently changing something. The temperature requirement set point is 100 degree, is frequently changing and our set point is not maintained, then this removed by this undershoot, overshoot and hunting removed by this derivative controller. What they are doing, they just predict the future error, what the future are going to be happen in the future, okay, what are the error is going to happen in the future and what are the present error, they accumulate all the error and after that predicts this error and after that they generate a control output which perfectly remove all the error, but they cannot remove the steady state error, because this is for the undershoot, overshoot and hunting, okay, derivative controller, and they just remove this undershoot, overshoot and this hunting from the system, because the derivative controller where it d by dt of ESS, Okay, rate of change of error. Okay, derivative controller main purpose is rate of change of error. They just check the rate of change of error, whatever the error is changing frequently, what are the future error, what are the past error, they look like this. So this is the basically derivative controller. Now I think you can understand the PID controller. I will explain in detail with such beautiful example, and I also explain boiler 3 element, what are the boiler 3 element and why we are using the PID there, and why we are using in the jacket cooling water, how we are controlling the water in the boiler and jacket cooling water. So I will explain everything, each and everything perfectly. So now let's move on to the another question. Synchronous machine, why we are using synchronous machine, and what is the purpose where we are using this synchronous machine work principle. I will explain this synchronous machine separately because this is a very good topic, and most of the surveyor 99% they are asking this question. Definitely they will ask this question. So this question will take too much time, approx 15 to 20 minutes. I will explain each and everything. So better I will explain in the next video, separate video of the PID and separate video for the synchronous. Let's move on to the another question. What are the method to start? I will explain this also in later section. But if suppose somebody know about the synchronous machine, so what are the method to start the synchronous? Damper winding and pony motor. Pony motor is the external motor, and damper winding we are using. Because the motor first start as an induction motor, then when the speed reach to the synchronous speed, then we switch over and then it work as a synchronous machine. Okay, so these are the dampers winding, you can see here. These are the dampers winding we are using in a rotor. Okay, pole face of the rotor. This is the conductor bar which we are using, and these are end circuited. I will explain everything very perfectly after that. So let's start the commutator. Next question. Commutator in the soft starter, I already explained what is the commutator. The main purpose of the commutator is to just reverse the current, and make the rotation in the same direction. Okay, and it convert also into AC into DC. The main purpose is there. I already explained in the part 3 lecture. You can just go and watch there, complete explanation is there. So it you can read here. A commutator is a rotatory electrical switch in a certain type of electric motor. That periodically reverses the current direction between the rotor and external circuit. It consists a cylinder composed of a multiple metal contents. You can read this one. Okay. Preferential trip is also very good question. Preferential trip I can explain you in detail also, because this is also 10-minute topic. I will explain you preferential trip in detail in separate video. So no problem for this. And voltage regulation, and whatever the question you have also, if suppose I am not going to answer, you guys just comment on the section. I will make video on that also. Okay, so voltage regulation of the transformer. Now voltage regulation, what is the voltage regulation? Voltage regulation, it means to maintain the constant output voltage. Let's suppose your transformer is this, and this is the input of the transformer, and output is going to our household. Okay, this is the distribution transformer, let's suppose. So you want always the constant voltage at your home. Okay, so 230 volt is coming to your home also, so you want constant voltage always. Okay, but there is a fluctuation. If let's suppose there is a fluctuation, there will be some voltage drop because of due to resistance and reactance. Okay, because of due to resistance and reactance of the transformer, then due to this there will be some drop in the transformer, because due to this impedance, actually this is resistance plus reactance, term as the impedance. Due to the impedance of the transformer, there will be some drop of a voltage, and due to this the voltage output will be changed. Let's suppose now before your voltage output is 230 volt at house, but if the impedance of the transformer is more, if transformer impedance, okay, impedance is more, transformer impedance is more and more drop will be there, so voltage will drop, and it will come like 210 volts. So there will be drop in 20 volt. This is the, so voltage regulation, for good voltage regulation we have to maintain a constant voltage output. Even if a circuit goes from no load to full load. Suppose before there is no load on the transformer, and then suddenly it goes from full load. Okay, after that the load will increase and going from full load. So ability of a transformer to maintain a constant output voltage 230 volt and 230 volt at a full load, so that it will tell us about the transformer capability, the ability of a transformer to maintain a constant output voltage from no load to full load. Okay, so this is the basically term as voltage regulation. I explain you in very simple explanation, but this is not possible always, because this is ideal transformer not exists. We cannot maintain 230 240 volt at the no load and full load, because there will be some drop due to the impedance. So always there will be some losses is there are different losses. Core loss is there, hysteresis loss, eddy current losses, stray losses is there, windings copper losses is there, iron loss is there, various type of losses. Core loss is iron loss, basically same, and only difference in the ferrite materials. Okay, so there are the various type of losses. Due to this losses, let's suppose here 250 volt you are transmitting and you are getting 230 volt, so there will be some drop always, but we have to maintain a good voltage regulation for the proper voltage consumption. Okay, otherwise your public will shout why the voltage is not coming here and all and like this. Okay, so this is the voltage regulation. I think I explained very easily, so you can check here. So ability to maintain a constant output voltage as the load varies from no load to full load. Okay, so no load voltage, full load voltage. No load voltage, let's suppose 250 volt, and full load voltage 230 volt, and full load voltage 230 volt. Just you do this mathematical term, and after that you will get voltage regulation. If voltage regulation is good, then power factor also good, efficiency of the transformer also good. It means maximum load can be drawn by the transformer. Okay, so these are the very important. Okay, you understand? Transformer, when a transformer supplies current to the load, the internal impedance, resistive and inductive of the transformer causes a voltage drop. This results in a lower secondary voltage under the load condition compared to the no load voltage. Okay, good regulation, a lower percentage indicate better voltage regulation. Poor regulation, a higher percentage indicate poor. Percentage, it means impedance. More and more impedance, the voltage regulation will be poor. Okay,